Hello. I really need some ice cream to help me deal with this. Okay, the camera is probably not quite pointing straight. Let's fix that. Let us fix okay, I did a bunch of more stuff. And it still isn't over, although we're maybe getting there. So like here, this move is coming out wrong. This is just a move. We're using a thing that we already had. Wait. Maybe these are right. I don't think so. We're going base pointer minus whatever. It looks to me like this is a fuck up. Okay. And then that fuck up is then affecting my mul here. This mul is supposed to be... It's supposed to be a 2-register mul. So we have... Our backend is not doing some kind of Rex fucking situation. But that's not just confined to this. Except then these actually look fine. I have no idea what's going on. Now they're teaching algorithms in Python. Switch to another school. I know, let's teach in a language that doesn't have a debugger. What a great idea. We don't want people to be able to debug their fucking programs. Fuck you. Teaching Python wrong? Okay, that's extra good. Does the Python debugger not count as one? I don't know. I don't know if it has one now, actually. It used to not. If it does now, that's a step forward, I guess, if it's good. Okay, well it sounds like it doesn't do that much, but it does sound like it's better than no debugger, so that's great. Okay, what is going on? What is going on? I'm going to set a breakpoint where we generate that mul. It's at line 32. Why did it? Visual Studio is so bad. Put me at my breakpoint, asshole. Like, what? Okay, I get to guess where the breakpoint is now. Oh, we're in the wrong file. There we go. Conditions. Oh no, I used a dot instead of an arrow. Stop the universe. Okay. It's the right one, apparently. So, we vreg prepare. P sub 0, P sub 1, P sub 2. That doesn't seem very good, but okay. P0 is RAX, so we don't spill it. I guess the logic being we knew we were going to overwrite it. So we spill RDX, but it doesn't have anything. Shuffle registers, what does this do? And basically nothing. So, oh God. Okay. Cool. Wait, more? Okay, we outputted a move there for some reason. Next time, that's probably one of the moves that's fucked. Okay. We're still 0, 1, 2, so our machine is RAX. Now, the whole reason I'm doing this code, I had to do the shitty unsigned mul for x64 because I couldn't figure out a better way to do it. So now we're going to save this. This is move 64 into RAX of P sub 1, which is just going to be all right, size is 8. So we add the rex and then that, the move, the 8B. I should be writing this down, but maybe we'll have to step through it again. Wait. This doesn't fucking seem right. How are R, A, and B 0, 1, and 2? I mean, I guess. Okay. We're doing a size 1. Okay, that's correct. Rex is 0, so we don't output that. But we are putting F6 /4 and then we're putting the output in P0, but we don't have to. And then we write that back to the register. Okay, that's a disaster. It's not going to fucking... Wait. Why didn't we... Wait, did we screw it up? We did. Wait, we're back at 5 times 17 breaking. I wonder if I was running this with the wrong options and that's why I was confused. Okay, hold on. Hold on. So we die on the first multiply now. Okay. What's going on here? Mol ALDL. Cool. It's 85. Okay, RAX. It's got junk in it. Okay, maybe and doesn't set the flags. Oh, I put it wrong. This should be jump if equal. If we're 0, we don't throw. Okay. That's the last thing that I sort of did. Okay. See, because x64 is so fucking amazing, we have this unsigned mol instruction, and it usually, the reason I'm using it is because it usually puts the upper part of the mol product in D and the lower part in A. Except if it's a 1 byte multiply, then it puts the upper part also in A. Why? Because fuck you, that's why. So then I'm like, okay, we'll AND it with FF. All right. It's still broken. Wait, I didn't compile the compiler. Once there's like 3 things to compile, it gets going. Okay, now we made it to the end. And this is supposed to overflow. The operand type is U8, but 700 does not fit into U8. Okay, that's good. That is good. Okay. Let's check the code. So maybe when I left off, when I was working on my own, oops, maybe I just was missing a step or doing. I was hungry. I needed to go eat, and I hadn't yet. Okay, so this assembly, what does it look like? We load C, we load D. We do this twice for some fucking reason that we could figure out later. I don't know. We mull. We move that back into memory. We AND RAX, and it's got an O2 in those slots. So we're going to be like, bro, it's not equal to 0. Okay, so that looks exactly like what we want. Okay, so let's test some other sizes, like 10,000 times 7. 10,000 times 7 doesn't fit. But what about 10,000 times 6? That does. Okay. What about this times 2? That should be fine. What about times 3 though? Okay. Let's try it with U64 times 2. Times 3. Guys, I think we did it so far. We have one by one gone through the multiplication cases. We did signed in the previous stream. Now the question is, do plus and minus fucking work? Which I guess we'll test now. And then I have to figure out how to do all this in LLVM, which you know how much I hate LLVM, all right? Okay. What if I plus it? I mean, that sure appeared to work, right? U32, U32. We're going to have to make systemic tests for all this stuff, but all right. And then 8. Boom. I mean, it's working, guys. I don't know what to tell you. Uh-oh. A minus B. Minus for unsigned is not working. Okay, minus for unsigned is not working. Let's try that with a different size. EFFF. Yeah, that's not supposed to compile, guys. I said that on the Discord. It's not supposed to compile. We only parse identifiers there right now. Chill. Chill. It's like you give people something and they ask for a million things. You missed my message, yeah. Well, I only put it in today. What about where a times b equals 2 to the n? That should work fine. Let's test it. A, that would be literally 8000 times 8000, right? No, times 2. No, yeah. I mean, we basically did this. Okay. So minus for unsigned is not working. We did a bunch of plus tests. Let's look at plus and minus for signed for a second. Boom. But this will go. Boom. So that's great. Let's just do signed real fast. Boom. So I feel pretty confident in this one because, like, this one doesn't require all the gnarly mountains of specialized code. It's just checking the carry bit on the operation that's already supported, right? It's very clean compared to the other shit. So yeah, that all works fine. So, okay, so our mystery is minus for unsigned. How do we... So the thing is, how do we know if a subtract went past 0 if they're unsigned? Okay, I could do something different. I could do, I could just say A is greater than B. All right, let's just real fast look at unsigned, right? Unsigned. Easy. We do A minus B. And we get 57,000. That's not right. So that has to get That has to get doodle whackered. All right. So subtract A from, no, move A to C, sub AX minus DX. And we'll look at the E flags on the sub. Okay. 285. Flags. 2, interrupt enable. All right. 8, sign flag. Parity flag and carry flag. A minus B is greater than A. That would do it, yeah. Unless B is a bigger type than A. Well, fortunately for us, by the time we get here, everything is forced to be the same type. So yeah, we could literally say, is the result bigger than either of the inputs, really, right? I think. No, that's not true. Just then the starting one. No, I think the greater than A thing is probably the move. Compare A, which is P sub 1, with the result, which is our machine. See, the thing is, we might have overwritten it. We definitely overwrote it. We definitely overwrote it. That's ass. So we have to save the value. Or we could do this before we actually do the subtraction. Well, It's like I'm trying to summon the will to deal with these stupid fucking problems. So either I do the compare before, and then I have to save the result in a register, and then compare that against 0. That's not very helpful. Or I have to copy into like a side piece here, you know. I have to have a little side piece. So anyway, we're going to compare this with saved A, which does not yet exist. And we're going to go jump if less. We don't have a jump if less. Fucking JCC. JL is OF8C. Except we want 32. JL relative 32. Let's double check. Yeah, we don't have it. JL relative 32 OF8C. What am I going to do to celebrate 4th of July? I might go to the gun range, but I feel like it might be busy on the 4th of July. I don't know. We could do that. So we need our saved A. So we're going to factor the is signed. We're going to do this. Okay. We're going to do all that fucking crap. Oh, wait. Fuck. We have to do this. This is all thanks to someone at fucking Intel. Thanks, guys. Thanks, guys. Else, assert. Okay, we're going to have int saved A, no check-in explain, assert saved A not equal to -1. No, minus down here, minus 50 DKP minus. Okay, we're going to say, motherfucker. This is so stupid, dude. I don't know. I don't know if this does really what I want. But I think maybe it does. We're going to see. I think this is going to be this. And then we're going to go move 64, output saved A, P sub 0. We don't fucking have P sub 0. God, this is so... Guys, I've been doing this all fucking day. It is so unnecessary and so fucking stupid and hateful. I fucking hate it. Okay, we can't do this yet. We can't do this here anyway. Fuck! We gotta put... Just fucking make everything not be such a piece of shit, please. Okay, please. It's like unbelievable. Like this computer that I'm typing this on is amazingly fast. It's also a fucking giant piece of shit. Both of these things are true at the same time. Okay. Put this down here. We do this fucking shit. Except we can't do it here either. We've got it, because by the time we get here, our A is stomped. So we've got to fucking... Guys, I'm ready to throw my computer out the window. We have to invade our core function to write this thing out. Or we have to factor the core function into two pieces. One which does the register deciding. I'm so angry right now. And it's not just for this. Like, yes, I've wasted many, many hours today doing stupid shit. But like, again, every single programmer in the world suffers from this, directly or indirectly, right? Directly, if they're doing the kind of thing I have to do right now. Indirectly, because all the tools they use are this much worse because all the people who made them had to deal with all this all day. Okay? Literally everything is worse because Intel won't get their act together and clean up their shit. For example, that's merely one of the things that would make everything better. I need more ice cream. All right. So let's look at print math bin up. This should be trivial, guys. All I'm trying to ask, the only thing I'm trying to ask is A greater than B? Okay? Gordon Moore has made it so hard to ask is A greater than B that it's taking a long time, and it's going to result in very complicated code that is bug prone. Did I see all the dead heads? I saw some people walking by. Like, literally, that's all I want to know. Okay? Literally, I just want to know is A greater than B? It's just they make it so fucking impossible. All right. We could probably get rid of this part. Anyway, so I think what we need to do is factor this part out. And pass, because we don't call print math bin op that much. And I think this is old. We shouldn't get here at this point. So we're going to go assert that these aren't -1. Or because the problem is with all this other stuff, see, I would have to do this. Here's what we're going to do. We're going to have a flag called don't use RDX. Okay? Thanks for all the subs. I hope the people appreciate it. Okay. I'm having matcha flavored ice cream. Okay. We're going to have a stupid hack flag. It's horrible, but if back up A into RDX, it's fucking stupid. We're going to do this thing that we were going to do elsewhere. I mean, the problem with this is this assumes we're not going to get RDX from this. If you check overflow on A less than B before the subtraction, you don't lose the values. I can't do that. That's the problem. The way the code is factored, well, first of all, that's what I was saying before. What do you mean by check overflow? You mean just storing it in another variable. All right. So we have to store something in a variable either way. You might as well just store A. But what I'm saying is there's no fucking place to do that without invading our core routines that we're trying to keep clean and filling them full of shit. And it makes me very angry. Because there is no, the higher level routine that we were editing there doesn't know what the registers are. And then we pick what the registers are, and then we do the add, and then we return. So we have to put some crap between picking what the registers are and doing the add. Can I just get a random machine register that is not in use? Pick temporary register. We're going to do this. Temp is going to be pick temporary register from this exclusions pointer, GPR min, and GPR max. Okay. I don't think we have to spill because I think this will spill for, yeah, that'll spill for us. And I don't think we have to. think we're going to do this up here, so we don't have to worry about that. Temp star back up A equals temp. We're going to no check in here. All right. And then we're going to again go move assert P sub 1 is not equal to temp A. Temp A, I'm a vegetarian. Temp A. Move. Move 64. Output. Temp A, P sub 1. Okay, so that's the backup. All right. God, this makes me so mad. Okay. So now, when we're down here, oh wait, I put a machine. Yeah, this is saved A. Okay. I only want to do this if minus. All right. So that's null. That's saved A pointer. Okay, so if we do all that, then when we get fucking down here, we can do that compare. Oh my God. This is just, like, this is how code becomes bad, is when you have stuff like this times 100, right? This is just one thing. And it's fucking stupid. Temp A. JLT relative 32. Oh, because it's JL. JL is like Superman's mom. Didn't work. Didn't work. Let's just see what we got, though. I'm ready to give up, guys. I'm ready to fucking go work at Five Guys because I hate this so much. All right, so we've got our CX and BX. Now this is CX minus BX, putting the result in CX, right? Okay, now, I'm really confused because nobody's fucking backing up the C register here, by the way. RCX looks like it was copied from RD. What? Okay, hold on. I wish I could just put comments over here. Okay. Right, so C is copied from D. But that's not... That's not helping. Because then we do the subtraction. And then we're comparing AX to CX. Oh, wait, that's what we want. Okay, wait. So this isn't going to change A. This is so confusing, guys. Yeah. Okay. So now we want to compare AX with CX. So AX is our store. I see. It was stored up here. And then all this other stuff happened. Okay, I gotcha. Now, we compare AX to CX. It is less. Oh, we want to jump if not less. Wait. So AX is the original A. No, it is less. Okay, this is a jump below versus jump less fucking problem. That's what it is. We don't want JL, right? We want JB. Right? Doesn't that make a lot of sense? Fuck, it still doesn't work. This is so trivial. Just fucking work, Jesus Christ. Okay. Oh, I didn't recompile something. We still got a JL. If you want to succeed in the games industry, press F7. Still didn't work, though. These are the days that really are not the ones you remember when you remember the golden days. Okay. JB. Right? So AX is less than CX, which means we went up by subtracting. Wait. We want not below. We don't want not below. Fuck, what do we want? See, because this is this confusing thing because the terms are turned around in my mind. Let's swap the order in the compare. Okay? JA. Still doesn't work. Oh, wait. Hold on. Got to do that one. Still doesn't work. What? How many? What do I have to type to make this work? Like every single thing has been like this all day. It's fucking horrendous. Okay, CX is above AX. But we don't want jump if above. We want jump if not above. What the fuck is wrong with me? Why is this so confusing? So jumping, see, this is another confusion. I keep thinking that jumping means jump to the error handling. It doesn't. It means jump around the error handling, right? So you actually want jump if below or equal in this order, right? Which means we want JA in the other order, right? So if we swap them back, no, because we want jump if above or, like 0 is okay. Okay, so like this. God damn it, dude. JAE 83. It's like never. This is what hell is like. It just goes like this for 1,000 years. Hey, look! And then you get to graduate to limbo. We finally got it. Probably. Let's try turning that around. B minus A should be legal. It is. A minus B. JAE jump around errors. That's exactly what it is. It's truth in advertising. Because it actually is confusing. Yeah, it really is very, there's so many things that are so confusing here. And it's, okay, here's the question. Like when I program higher level stuff, it's generally not this confusing unless it's really actually something that's super complicated. And somehow when we go do all this low level stuff, it gets confusing sometimes for no reason. Like this was literally, we want to know if the number got higher when we subtracted. That's not a very hard concept. And yet somehow I made like 17 bugs on the way to doing it. And it still may not actually be correct. Like, what is it about? I think part of it is just the conventions with which all these things are done are fucking confusing. I talked before about how, you know, above versus greater, that terminology doesn't help anybody, right? It should be signed greater or unsigned greater. All right? For example, that would remove one element of confusion. And you just got to do that with as many things as possible. You still don't get why you have to comp values instead of just jumping if carry set or not. Because I don't know how to do that. I couldn't figure out how to do that if the values are unsigned. Looking at the things, it looked like it set all the carry flags and stuff as if it were a signed subtract. So I couldn't tell what flag to check. Now, maybe I should have asked ChatGPT how to do it, and it would have said, type this Python script. Yeah. No, I mean, I agree. I should be able to do that. Talking about the many points of confusion, why can't I just say unsigned subtract did it under... Like, that's all we're trying to do for hours is unsigned subtract Did it underflow? Literally a trivial fucking question. And it just turns into this gnarly thing. And you think this is what CPUs are supposed to be good at, right? Comp is just sub without storing the result. True. True. Which I guess means that there should be a way to do the sub. Right? But like, I just don't understand. I just don't understand. It's true. I've observed this before. Comp is just sub without storing the result. Yeah. So then why can't I just do the sub and the jump? The reason we're doing all this is that didn't work. You just use the branch you have right now after the sub. Okay, so you're telling me this makes sense, but it's just one level too confusing for me to see it. You're telling me I can delete all this bullshit that I added about backup A and all that stuff, which I would love to do. Believe me. That would just make me so happy right now. Well, we can leave all that stuff in for the moment, and then just here, you're just saying I don't do the compare because I did the subtract. See, I thought the reason why I didn't try to look for something like this was because when I looked at the documentation, it looked like it was doing the same thing with carry flag and overflow flag, and those were the only two flags. So I was like, I don't see a way to do something different with signed and unsigned, but I very easily could have made a mistake there. Look, it fucking works. Wizard Pepper. Unbelievable. Okay, so that was like an extra hour. Yeah, that was a VIP move right there. Okay, guess what? Look at all this trash. All this trash. But now a lot of programmers will have this thing where they're like, they have this mental block where they're like, I worked so hard to make that happen. You know, I can't delete it, or I don't want to delete it, or I'm just tired. No, you delete that shit as quickly as possible. If you can simplify something that much, you do it. Even if it's literally what you were just doing for an hour. It wasn't quite an hour, but... All right, well, thank you. That was helpful. I still don't know why that works exactly. I just don't know what combination of flags that is. I mean, it says, right, JAE documentation will say... For unsigned, it's the overflow flag, but it's not. It's not, because that's what we're using for signed. Like, the whole reason we are doing all this, okay, is because This didn't work. We tested this. That's not. This didn't work, so I had to do this. Because this was giving us like signed results. OF for signed and CF for unsigned. Well, I'll try to figure it out at some point. Anyway, this is good progress. This is 2/3 now of the things. By the way, this is only overflow checking for plus and minus and times, which admittedly are the most important ones. I should have just started with plus only. Like, that would have been much easier and we could have rolled it out incrementally. We're still rolling it out incrementally because we don't have overflow checking for unary minus or divide. But those almost never matter. The link you sent earlier has bit diagrams. I missed the link. Why is the carry flag set during a subtraction when 0 is the minuend? Oh, that's a fancy word. Implement some functions in assembly. When subtracting two unsigned integers, the carry flag is set when I subtract any number from 0. Why is the carry flag? Because you borrow. Oh boy, we're using minuend and subtrahend now. Haven't heard those words since college. Yeah. Minuendo. Okay. I still don't totally get it. I did like sometime a long ass time ago. I went through this stuff and sort of got it. Like the way that it works, right, is like the sub or whatever doesn't know whether the numbers are signed or unsigned, right? That's like an interpretation. And I don't remember why that works. And so the reason we use two different compares that go off different flags is that is when the interpretation is put into place about whether they're signed or unsigned, but the actual subtract doesn't care, right? Okay, well, guys, we could take the W here. But then if we take the W here, then we're in for a truly dire time. Because then it's fucking LLVM time. And God only knows what we're going to do with any of this stuff in LLVM. But we'll take the W if we indeed deserve the W. Why are people telling me about two's complement as if I don't know what two's complement is? Okay. Low-level virtue signaling machine. Is that like Three's Company? Yeah, it's after Chrissy left the show or whatever. It was down to two's complement. The number in square brackets is which thread is running that test. I have not written the thorough test. We sort of went through some tests by hand, and everything seems to work. But we have not yet done... See, I don't want to check in official tests because those get run on all the backends, and they will fail on the backends where it's not implemented, right? So I kind of want to get them working and then make the real tests. I kind of want more ice cream, but I kind of don't. Yeah, I'm kind of tired now, but I want to keep going. Let's take a break. Let's take a 10-minute chat break. Before I face the peril, let's take the W, and then I'll face the peril of LLVM in a minute. This is going to be... I mean, hopefully we can make it nice, but, like, I'm not looking forward to it. Okay. Let's make sure our previous W's are W'd. Yeah. Great. Should you have some caffeine at 6:30? I mean, that's a question. How do you react to caffeine? Is the issue. How do you make LLVM do it? Make the correct IR? I mean, I'm probably going to do it a lot like the C++ version. Because I don't know how else to really do it. I mean, probably you can test the carry bit and stuff, but given that this was this painful writing machine code directly, I think that approach is going to be way worse with LLVM. Although we could do a little bit of preliminary search, like LLVM, C++ API, which we never can find. Nobody in the world uses the LLVM API as far as I can tell anyway. LLVM, C++ API, detect addition overflow. Okay, this is C++. That's not. See, you say LLVM and everyone thinks like, oh, how do I turn it on in Clang when I'm compiling C++? It's like, okay. Efficient integer overflow checking in LLVM. Dude, on the one hand, this Regehr dude seems okay sometimes. But then he's like all about the UB, which I fucking can't stand. Okay. I don't. This is not helping. There are literally 0 hits. Somebody is linking in llvm.org. Let's see. Usub with overflow intrinsics. Perform an unsigned subtraction and indicate whether an overflow occurred. Okay, so the I1 return value is a Boolean of whether the overflow returned. So are there unsigned versions of these as well? Like these are all I32, right? Can I put like a U64 on here? Oh, this is okay. U sub is unsigned sub. S sub is signed sub. Okay. So I have to frickin' load these like loading intrinsics in the API is itself. It's very random. It seems to do like weird name matching heuristics on the string that you pass it, and like that's a complete nightmare. But we can give it a try. So do we have ads as well? Yes, you add. Okay. This might actually kind of work out. Okay. So it's kind of cold in here. Now I'm going to go edit my thermostat. I want to drink more tea, but I've had so much caffeine today. So much caffeine. All right, well, I feel for the dude who implemented these intrinsics, given that we just did and it sucked. Okay, so we'll do it incrementally, but it sure feels to me like it should be kind of straightforward because the API they are presenting us with is very uniform. Try caffeine-free tea. Yeah, I've got some. I think I'm just tired of tea today. I don't know. I had a bunch in the morning. Someone's linking a code gen. Let's see what they teach about code generation in the university these days. For data processing, okay. This is already weird. I mean, this is like one class a week. It's just hard. Like each of these topics is very, like register allocation. Like how long do you actually need to talk about register allocation? Maybe quite a while. So like doing that in one day, I mean, it's an overview. It's an overview. The data processing was because of political stuff. It's like the story about why linear programming is called linear programming. I mean, that seems fine. Like one class a week seems pretty weird to me. But then again, when I was in college, a lot of my classes were effectively one class a week because I just didn't show up all the time. So maybe it's fine. 2 hours is nutty, the brain gets tired. I mean, yeah, but also it's a muscle. There's another compiler class and classes can't overlap. Yeah, I mean, I'm not surprised about that kind of thing at all. It just always amazes me, right? Now that I do, for example, compilers, I've spent so many, I don't even know how many hours making compilers. There's just so much to know about it. Like, you just can't teach it in a university class, really. Right? So it's just a very hard like, yeah, all you can really do is give people an introduction. Makes you think school is a scam. Well, I do think it depends on what you get out of it. If your expectation is that you graduate a master programmer, as some advertisements sometimes claim, yeah, you're not going to get that. And if the college is telling you they're going to make you into a top programmer, they're lying. But if it's like, we're going to tell you, we're giving you a basic educational foundation of what are all the things that you maybe need to know, I mean, that's what they can do. So it all depends on how it's positioned, I think. Use it as a 4-year buffer of intense self-study. Yeah, I mean, that's kind of like what I did, except I also played a lot of video games, so it maybe wasn't as intensive. But I do think like all the people in college who end up being the best are like the ones who spent a lot of time on their own projects. Like, that seems universal. Anyway, all right. We're going to delve into the LLVM situation now. Let's check. We should have compiled by now. Let's just verify. Okay, so that's good. LLVM. We're not even going to try anything yet. So we do emit math bin op. And here we can do it a little differently because we're just going to call an intrinsic. I think we're going to put it in here, right? And, okay, that's float. So I think we're just going to put it in plus minus times. This is a little weird. I don't think this should be necessary anymore. So one thing we can do is assert on stuff like this. But I'm sort of in the mood to do this one at a time. So we could do add sub times. And we could even initially not even check for overflow yet. Just call the overflow checking version. Right? And then we'll see. Okay. If we can. Anyway. So we should be able to call the overflow checking version And then still, yeah. Okay, so we're going to do that. And I'm just going to do this. Oh, we got some thunder. True, false. Okay, that's great. We never... I think this is a hack for stuff that's no longer true. Okay, we changed it here and we pass all the tests. So like, I'm going to go back here because I think this can go away now. But we'll leave this in here for a little bit. Anyway, LLVM. So we need this intrinsic. There's a way to load intrinsics. Okay. I'm just going to load them. See, here's the thing. Because this is an opaque API, I have no idea how long it takes to load an intrinsic. So what I always do with literally everything in LLVM is I get it at startup and I store it in a pointer. Maybe that's useful, maybe it's not. But I'm going to go function, overflow, add U64, 32, 16, 8, and I wish there was one that just dispatched. Like, wow, they're going to go make all this stuff. They might as well make me one that just dispatches. Okay. Intrinsic mem comp. When do we function create? Okay, intrinsic. Let's just do it for one. Function create. Function type get. I never remember what all this is going to be a brackets. How does this even work in C++? Wait, I could use the name. Hold on. Can't I just use the name? How do I get an intrinsic just from the name? We were doing that with WebAssembly intrinsics. Okay, get or create function intrinsic name. Helper module get function name. I mean, can I just do that? Module get function of LLVM uadd with overflow I64? Does this work? That'd be easy if it does. Now print lol. Am I using the IR builder? Yeah, I guess. I don't know. Sometimes. Okay. Clearly, I'm switching languages too much. Okay, it's not giving me anything. It's giving me a load of zeros. How do I fix that? LVM dot. Do I load any other ones? No. LVM API get intrinsic by name. So it's making me do the type here. This is not any better. Like, I want it to tell me the fucking type. It knows the type. Oh my god, someone's typing so much spam here into chat. IG auto compound is builder create call intrinsic get declaration. What the fuck? What are L and R here? What does this have to do with any of these other things? Okay, so this is what was just pasted. What is L? Why do I have to do this to get the predefined i64? Dude, I just want to throw the computer out the window. What even is this? So, okay. So each intrinsic, I guess, has like an enum or a data structure. This is the return type and the argument types. But create extract value. Okay, so this is return value 0, return value 1. But I don't want to create the call yet. Okay, so this is the thing. I don't actually want to call it yet. I just want this part. So kind of what we're saying is this is the actual part that we're looking to do right now. Does get declaration return me something compatible with? Let's just see what happens. Module, intrinsic, uadd with overflow, i64. Now why aren't we putting the comma I1 in there? I don't know. Fucking. All right. Hey, we're getting it. We're getting the intrinsics. Do I have type I1? Dude, LLVM is so aggravating. Okay. So we put the I1 in. It's still giving us answers. That is fine. Okay. So I'm just literally going to do this. U64, 32, 16, 8. Okay. 32, 16, 8. And then we're going to do this for the signed as well. Boy, this is exactly the kind of code that ChatGPT would be really good at. Okay. Okay. Type i16. Okay. We got addresses for all of these. Now, who knows what's going to happen when we call these addresses? Never try to make overflow checks for signed 128-bit multiplies. So you mean 128 times 128? I've never done that one. Don't plan to anytime soon. Okay. Let's do sub as well. I'm going to do sub and mul. This is obviously a very productive use of everyone's time. Okay. Great. Wonderful. Glue code. It's so much glue code. All right. Let's actually use one of these. Now I kind of don't get like, can't I call the intrinsic without doing all this? Can't I call the intrinsic on i64 and it'll just dispatch it? I mean, I guess that's what this was doing here. It's just I don't trust that this is fast. I mean, I don't know. I don't have performance numbers. but I don't trust that it's fast. I could just do, like, instead of fanning this out here, though, I could just do that. Well, the problem with fanning it out here is, of course, now I need all the if statements and stuff. Right? Okay, so if we go back to this thing, what we want to do is here, if overflow, check, we do something, else we do something, all right? Same with minus. Okay, and same with times. Let's see if this times causes problems for us. If I put that assert false, does that fire? Because I feel like we had adventures in the past that may not be necessary anymore. No, not dash x64, dash LOVM. It's not firing. Which means we could delete that, which is great. Hey, do you guys want to see something cool? I mean, maybe we should have done this 15 years ago. Oh, shoot. Hold on. I got to go into high security mode to show you the cool thing. It's password protected for your security. Oops. Maybe I can't show you this now, because it might give away something that we're not supposed to. Let's see. It's hard playing sideways. You know, I never really did the game back in the day because I was convinced that touch controls would not be really that good, but they're honestly kind of fine. Oh, I was looking the wrong way. Let's try again. Okay, you get the idea. Oh, I missed. Come here, buddy. Come here, buddy. See? Easy clap. Easy clap. Turn down brightness. Yeah, sorry. Sorry. Does it have Bluetooth controller support? I'm not sure. We'll probably put it in. Okay, that was the cool thing. We are working with somebody else to do the mobile ports because I am spending all my time doing x64 machine language. Have I ever done mobile development? I did a little bit on the Witness, but not a ton. Not a ton. Okay, so this didn't go off. Oh, not x64. Not x64. So, oh, you know, the thing is, I kind of don't know if asserts work in LLVM converter.cpp. LLVM does this fucking thing. Maybe I need to put like exit 1 there or something. It like does some shit that makes assert not work, which is incredible. Let's see if that's still true. We upgraded quote unquote LLVM. So I'm just going to put this out here. It sure better go off where it is now. Because like any integer multiplication should set this off. Yeah. Okay, so asserts work again, which is great. That's fucking awesome. All right. But we can delete this because we took care of that. So now if overflow check, we do this, else we do that. And for now, it's always the same. Okay. So I'm just going to blast out the if statements because I don't trust LLVM to do anything faster than that. Oh, Emacs, what did you just do? What? It showed me the beautiful bison. Okay, so just for plus. Dude, I've suffered through a long time of asserts not working, so believe me, I'm happy about asserts working. Okay, also this did not go off. So those are all old things that we don't need anymore. This current register offset, I think, is trash, right? Like nobody ever sets this. This was an idea that I had that doesn't do anything. Like literally nobody ever sets this value. All right, we're going to have to delete that, but not yet. That was totally just some idea that we had. It's not how we ended up doing inlining. Okay. Anyway, so we're going to do plus 50 DKP plus. And we're going to say if size is equal to 8 if is signed. See, this is going to be the same fucking crap. Okay. And we're going to go, I'm going to do this thing, but now without, create call of helper overflow add S64, right? Like that. Okay. Something like that. 64, 32, 16, 8, and U64. It's just such a waste of time, dude. U32, 16, 8. Okay. So now, if we can do this and still get ads that work, is this going to give me the first return value? Or should I get that part as well? Because over here we did this IR builder create extract value. Yeah, all right. Let's... Going to do this. So op we're returning. So we're just going to say op equals IR builder. I don't know where to get that from. Create extract value compound 0. Okay. Although, I mean, honestly, we could do that down here. All right. What is the what? I guess it's value. And then we only have to do this down at the bottom. Okay, so we need this. So A type arrow size bool is signed. All right. Sorry, A defen. A type is the LLVM one. Okay. Well, let's make sure, because we've had a lot of confusion about not recompiling. I mean, this code's got to be doing some integer additions, right? Don't you think? I would bet it's doing integer additions in multiple sizes. So, okay, here we can do this. And I can go value overflow, create extract value 1. And now we want to do a compare. What did we do for array bounds check? Oh, we don't have, we need our arithmetic overflow, right? Is that what it's called? Yes. So we need to assign this. Interp arrow rs arithmetic overflow. Go to create function. Okay. Cool. Okay, so now we do all this stuff. We do something, and then we call arithmetic overflow, and then we jump over it. Now, these arguments we're going to have to fucking figure out. So next block. Oh, what a pain in the ass. What a pain in the ass. Okay, so we have a compare. We're going to look at that. We're going to create a successor block. Successor of arithmetic overflow check for add. I don't even know how you ever see that comment, but okay. Check fail block. Create conditional branch. Oh, dude, what a fucking... We're going to have to factor this into a function, because holy cow. Holy cow. Are we going to make a new string? We're going to be hashing strings every time. This is going to be so slow. Didn't know x64 provided that atomic guarantee on aligned accesses. I mean, Yeah, like, here's the thing. Here's the thing you don't get. Every modern CPU is maybe kind of RISC, kind of VLIW-ish. The x64 machine code that we were struggling with earlier today is not even real. It's just a programming language that you use to talk to the chip. As soon as you give that shit to the chip, the instruction decoder looks at it and says, dude, I don't want to deal with any of this shit, and turns it into a totally different machine language. That's just how these chips work now. So all that machine language is an API. It's not. So when you say, oh, it's a CISC machine because the instructions are so complicated, it's like, yeah, the instructions are complicated and I hate them, but they don't actually have very much to do with how the chip works. And in fact, that's a problem, right? That's why the instruction decoder ends up being a bottleneck and stuff, is because it's actually not really how the chip works. The real hardware really isn't doing that. I don't know what you mean by really isn't doing that. Like the Intel machine that I'm streaming on does that. Okay? The instructions that it actually runs are nothing like all that garbage we had to figure out how to input. That's what makes me extra mad about it. Okay? It's just garbage. Like nobody wants it. You're just agreeing with me. Okay. Yeah, I mean, I wish it weren't there. It's so frustrating because it's just an API. And the fact that it's literally just an API makes it extra inexcusable that it's approximately the worst API known to man. However, actually it's not that bad because at least this API does what you tell it to, unlike, a graphics driver or whatever. Or like a web browser API. Front end is not really a bottleneck when you are compute constrained. Yeah, I mean, it's definitely contextual when it matters. It doesn't matter all the time, for sure. It doesn't matter the majority of the time, for sure, but sometimes it matters. Would Intel AMD ever give us the real ISA? I mean, I assume it changes every chip, right? Like the thing about you not being able to see the UOPs is they could change their mind about what they are. And so that gives them useful flexibility. Like I am not saying it's a bad decision to de-sugar machine language to UOPs. I'm simply upset that I have to deal with the worst machine language ever made, right? That's all. This is what I don't get that's so weird, right? So one argument that people make, and I'm not necessarily disagreeing, but they all say, the instruction decoder is such a small percentage of the die, right? So don't worry about it. That was what people were saying for a while. It's like, okay, if that's true, just give us 2 instruction decoders for 2 totally different instruction sets and migrate over time that way. But they don't even care enough to do that. You know? Like, surely if it's like a decoder for a better instruction set would be substantially smaller than the current one. So it's like you multiply the amount of die taken for it by like 1.4 and you get a better instruction set. Like, I don't understand what the problem is. There's no monetary incentive. I mean, yeah, I don't know. I would do it anyway because it's obviously like it is obviously the correct thing to do engineering wise to clean this stuff up, right? And you would reap benefits from that. But they just don't care. And you know, stories are told. We got into this in chat earlier about like, oh, every time they try to change instruction set, the chip fails. So obviously that's why or whatever. Like it has a bad rep, you know. It's like Microsoft never wanting to make a Cyberpunk game again because they were convinced it was death, and then CD Projekt puts out a Cyberpunk, you know, ad, and like everybody goes apeshit about it. Yeah, like the reason these chips live or die isn't the instruction set necessarily. This is why we still get away with x64 instruction set, right? Like it doesn't actually matter that much to the performance of the chip. What actually matters is like how well what's going on underneath like deals with the workloads, right? So but that's so when people say, "Oh, the instruction set was different, so the and the chip failed, so we better not ever change the instruction set." I just think that's the wrong lesson to learn. Now, again, I don't see why you couldn't just have 2 decoders on the chip and the operating system controls which one's in use. And if a process is flagged, like you can have a flag in the binary of new instruction set, and if the process starts up using that, then you do that. Of course, when you context switch into the kernel and stuff, you would have to flip. But, you know, like, I think that's doable. Yeah, I just don't, there's not the incentive, right? But I would do it anyway. If I were like lead CPU architect at Intel, I would do it anyway. They could fire me if they want. Probably because no one interfaces with it but LLVM. Yeah, but that's what I was saying. You know, this morning I was talking about the cost benefit ratio, and like, actually, the benefit of backward compatibility kind of goes down as you have fewer people writing machine code, right? Because it's like only those people have to adjust if you give them new machine code. I don't know. I just want someone to make a new chip. Like I invested a little bit in the mill, although I don't know if that's ever going to happen. If Risk V gets their butt in gear, that would be great. Like I would just love to see a new chip that is more pleasant to program for. I would just like it a lot. Risk V was mentioned. Of course, it was mentioned in chat. That doesn't mean people are clamoring to use it. It's just so pointless, right? It's like the fact that the whole instruction set is fiction anyway just makes it that much more offensive that it's so hard to deal with. Okay, so anyway, going back to this giant thing. Yeah, I mean, this doesn't look great, but let's deal with it. So we want to compare with 0. Is there a create icomp in Z? Apparently not. Create icomp any. Do I have to make a 0 constant? Create icomp. Let me just, we must have an icomp any in here. Get null value. Okay. Okay. God, LOVM is so weird. I mean, it's not, it's what happens when you take C++ pretty far. Okay, so we're going to go auto comp compare is icomp naughty of overflow with I1. Like, why do I have to get the int1 type? Like, who fucking gives a shit? Right? Like, what is your problem? What is your major malfunction, Lieutenant? Okay, we create a next block. We create a check fail block. We create compare. Okay, I think this is the right order. Now, this set insert point means we're now putting the code for the call. Okay. Now, this call is not right because the arguments are not right. And we need to do our whole thing about, we need to make a I32 value of the flag, get value, create. How do I create a constant? Assign to big constant. Create LLVM constant value. That's our own function. We could use that, I guess. It's like, so frustrating. All right. Equals create LLVM constant value helper. U32, what do we call it? type code. Oh, it's a U16. Wait, why are there two types? We probably can unwrap this. We're above the definition anyway. Okay, we're going to do this. Constant, that's why it's a good idea to unwrap it. Type. Type arrow type. This is get int 16 tie. Okay. Just like that. We're just going to put 0 for now. Actually 80001. Whatever. We have to make that more of a value. Oh my god, so many. Create successor block not found. That's our own fucking function. I didn't expect the Spanish Inquisition. Okay, context. This is helper LLVM context. I'm just going to do that. This is code. Look at all the code. Look at all the lines of codes. Oh, literally. Probably that, right? Helper. Hamburger helper. Load R. Oh yeah, these arguments. These arguments are not. So we need left, right, type code, line number, file name. Okay, we got line number, file name. So we need left, right, and type code. We got the type code. Left and right are gonna be cast A and cast B. Okay. All right. Now, this is minus. Minus does not have overflow checking, but plus maybe theoretically does. Nope. Now we get to debug why that doesn't work. Should we, let's step in there and even, wait, did I x60? No, that's LLVM. Let's step in there and even see what we even got for that. Disassembly. There's literally no check whatsoever. Oh, cause I didn't do the thing, guys. This isn't on by default. Got to do that. Okay, this is great. This is like getting your first triangle on the screen. in Vulkan. So this is not right. This is not right, but we could fix that. This is the easiest thing to fix. These ones, I don't know. A measly triangle, that is right. But that measly triangle is the stepping point that you need. It's this, sorry, the sign that you're going places. I kind of want a chai, but it's kind of late for caffeine. You know what? Let's just relax for a second. And I'm going to take a little brain. This is Pomodoro. We're 2 hours and 30 minutes into the stream. So it's brain break time. How's it going, everybody? Get a chai. We could make a chai with just 1 squirt of chai juice. How's that? That's okay. We're going to do that. Okay. Now, I don't know why those numbers are so wrong. Oh, we're not thinking it. We're still taking our Pomodoro. Guys, I've streamed for 7.5 hours today so far. Actually, more than that. I'm like a pro streamer today. Pro streamer. $100 million kick offer, dude. I would take that. Some girls would turn the color of an avocado when he'd drive down the street in his Eldorado. It's my favorite color, red. Reddish red. I like reddish red. Okay, pass 1 on the froth is done. We're going to do pass 2. Wait, it's not. Guys, I accidentally had it set to cold froth. Why is there even such a setting? It doesn't make sense. Like 255.00, not exactly, a little more a mildly burgundy red. I don't know how to describe it. There's also some orange reds that are good too. Two bytes that could never be freed. Awesome. Okay, I think what's wrong with the overflow is these are not necessarily being cast. Like we're passing the things in, but we have to cast them to S64 to call the function. I think. So this is going to be another one that we probably want to, because this is dealing with float and integer and all this, right? Oh God, we have to sign extend or not. If is signed, recast A equals create SXed cast A to helper I64 or helper arrow I64. Okay, recast B. Okay. Otherwise, we're zero extending. This is the times when LLVM makes the most sense is when it directly maps to operations that you want, right? I almost flubbed that. All right. So there we go. Recast. All the girls would turn the color of an avocado as he'd drive down the street in his Eldorado. Hey! We got the numbers right now. We don't have the operator correct. All that is easy peasy though. We're gonna now that we got the hard one, we're gonna take a break, and then this one and this one are easy. That's just putting the right numbers into that type code, and we already did that in the other file. So I wonder, since I cold frothed it first, if it's gonna come out extra frothy. Andrew Tate opinions go. Okay, if you guys want to see a funny thing, here we're gonna have comedy theater. Maybe I'll get banned from Twitch for playing this video. If you haven't seen this, it's pretty funny. I mean,
all right, first.
it's called If Jordan Peterson Was a Nightclub Bouncer.
Shift, so we're gonna, keep dudes without chicks to a minimum, keep the talent a little high.
Hey, I think you ladies are looking for the barn down the road. We don't need you doing structural damage to our dance floor, fat pigs.
Okay, that.
It's very offensive. I'm just gonna put out there. That video is very offensive. We do not condone being very offensive. Okay. But I'm very happy that we got our things going. So our type code here is similarly I should just have a get type code function that takes interp op. Oh, op is something else here. bc bin op.op. The size. It is signed. All right. All the girdles would turn the color of an avocado. Okay, single pump chai. We're gonna let that mix for just a short amount of time. Mr. Peterson. All right, we got frothy chai. It's good stuff. Mmm. 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 All the girls would turn the color of an avocado. Yeah. We had this as U32 here for some reason, and that's wrong. All right, so get type code. It's going to go in converter help. Bytecode, I don't know. That's not the right word. Okay, we get the type code. All right. So what is this called? Bytecode bin up. Jordan Peterson sent me a signed copy of his book, by the way. I was reminded of this when I was packing up my stuff in Florida. It was very nice of him to do that. I wonder how he heard of me. I have no idea how he heard of me. Did I read it? I haven't read it yet. It's been on the list for a long time, and I haven't been getting through books. It's definitely a thing that I've been doing is on weekends. I've been doing less internet and more books and stuff, and that's been very good. And so I'm going to continue to do that and hope I can make my way through the stack. Now, the problem with that is that it conflicts with the idea of doing a weekend project. How am I supposed to keep doing all the badass weekend projects and also do weekend edification? I could split it 1-1, one day. Be careful of Bill Gates GMO mosquitoes. Yeah, I am not in Florida now. I like my town in Florida a lot, but I've now moved to Colorado mostly. Just stream reading a project. You got bit by a mosquito? Well, I get bit by mosquitoes all the time. They seem to like me more than a lot of people. And I definitely got bit by a bunch when I was in Florida this past week. So maybe I've got dengue fever now. All the girls would turn the color of an avocado. Hey, look, we got the operator correct. We got the type correct. GG's. I think we're good on let's do minus won't throw. Let's do signed. Boom. But if it's 0, it's fine. And if it's 1 but E, it's fine. But if it's 2, no good. But if it's, how about minus 32700 and minus 100. Boom. But minus 10 is okay. Working great. Working great. One to 3 genes that indicate whether you'll be bitten by mosquitoes or not. Then I should change my genes more often. Well, mosquitoes don't really interact with your immune system directly. I mean, they do if they're carrying a pathogen. But they're not really like on you long enough for your immune system to do anything. All the girls would turn the color of an avocado. Okay, so this is great. We actually realistically could have this done tonight, which is awesome because we started today, I think, with none of this even working in x64. We got all of x64, and we've got a third of LLVM. And the rest, we could ask ChatGPT to complete this at this point, and it would be bad at it, but you know. We just do this for the other two. God, it's so much code, dude. All right. However, we're going to factor out all this stuff. We're going to say, oh, it's such a disaster, dude. Look at all this. So basically, we want to do all this 3 times. We want to do it for minus. We want to do it for times. And we're just going to splat out this part every time. Up to here, and then we're going to call create overflow check compare create arithmetic overflow check for helper we'll pass IR builder. I don't know where to get that. And overflow and we probably need some other stuff, but we're going to do this. And then maybe we'll take the W. We should run all the tests, by the way. Okay. Boom. BC. We didn't pass that. Cast A and cast B. Is signed. Dude, computers can just do so much stuff. It's insane. They just grind through BC to LVM value. What? Overflow. Yeah. I was thinking about doing it in that order, and then I switched it over here, and then my brain didn't switch it over here. Oh, All the girls would turn the color of an avocado. Okay, let's make sure that's still false if we do that. Boom, great. Let's run the tests. All the tests would turn the color of an avocado. Okay, literally, you know what? I said we would take the W, but I'm just going for it. Because from here, it's a straight on. Straight on till morning. Any other recommendation besides Golden Monkey? I like the Harney and Sons Hot Cinnamon Spice in loose leaf form. I just bought another bag, which I forgot to dig into today. It is unopened. This is one of my favorite teas. Yum, yum. There's lots of good teas, though. Does it make sense to view a software project the same way you would like any... No, if you build software the way you try to build a bridge, you'll never get the software done. Software is way more complicated. C++ is bugging. This isn't C++. This is us running hundreds and hundreds of tests. We ran 600 tests in debug compiler. All right. Gonna do it again. Oh, he said that when I was compiling the compiler, not the tests. Well, it is true. It is true that C++ compilers are all slow. Oh yeah, the girls would turn the color of an avocado. All right, so that went. This is going to take a bit. Debug compiler LLVM backend. But, I mean, if this works, we're kind of done. except that we need to make all the tests and stuff, and it would be foolish to assume that some of those won't fail. Oh, by the way, though, here's the thing. We're not, all that stuff is doing is mainly testing that we didn't break stuff, because those bounds checks are not, they're not on by default, I don't believe. Although we could check that. But this is fine. This is good enough for us to check in. All right. Well, overflow checks, not exactly balance checks. Uh-oh, I have a no check-in. Oh, these. Lol. Okay. This is pretty good. Guys, I'm kind of tired. We have streamed 8 hours. I've worked we streamed more than 8 hours. I've so far worked like 10 and a half or 11 hours today. But there's still time left. Let's at least start documenting this for the people. Oh, we could do this too. That's kind of mindless. All right. The compiler now has the ability to instrument code with checks for arithmetic overflow for binary operators plus, minus, and times. This is settable on build options. Set check to dot fatal or dot non-fatal. It currently defaults to off, but we change this in the future. Okay, so there's sort of a policy question, and I'm going to be too tired tonight to really think about this, but what do we set by default on debug builds? It might be annoying to have a hash function or a random number generator. Fail due to this stuff. But if that I mean, we could do some silly things about looking for the name of the function, and like if it contains the word hash or random, say, by the way, you probably should mark it. Anyway, so there's this question. We have this set optimization level function, for example, where you say, hey, I kind of want a debug build or a release build. And if you care, you can go tweak options separately. But a lot of people will just want to call the function and not worry too much about it. And when we do that, we want some policy for like, does a debug build turn this on? Right now, I only turn it on for very debug because I'm not sure what it's going to do for performance. But we could benchmark it and stuff and see. The other thing I was thinking is, like, hey, usually if there's a mistake in your program, it's more likely to happen in the smaller types like U8, U16, S8, X16. And those are less common. So if we just instrument those by default in regular debug builds, it probably will not slow code down that much. Maybe. You think you can do about 4 hours of work in a day that's actually worth 4 hours? I mean, that's a muscle is all I can say. There are definitely people who can work 16-hour days and all 16 hours are good. I can do that. I can't do it for more than like 9 days in a row, but I could definitely do it. Or I won't say can't. I've never done it for more than like 9 days in a row. Yeah, the question of how much slower is it, I don't know right now. Especially like I don't know what LLVM's doing for any of this. It could be quite bad. Let's go into Sokoban. Let's build a release compiler. That'll be fun. Let's make sure our check-in was okay. Hey. So I totally started thinking about something else right in the middle. Anyway, so we've got release compiler. I'm going to build. Oh, I'm going to go into the meta program here. And I'm going to turn on arithmetic overflow check. Just for now. And we're going to see what happens. This is still making a debug build. Okay. Is it? Let me just print cowabunga. So I know that that's the right one. Yeah, okay, we cowabunged. So this is a debug build with maximum, because there's no, it'll probably crash from some kind of arithmetic overflow, yeah. We tried to compute blah. This looks like a hash function. Those are both very large numbers. Let's go see. We also might want to implement some kind of like easier way on the operator. There is a way, but it's not super nice. So that, before we turn this stuff on by default. Okay. Stack push. Yeah, this is a hash. Can I do that still, or did I take that out? Nope. Can't do it that way. We'll do it there. There might be several others of those. I should keep running this in debugger. All right, we got pretty far. That's another hash function looking thing. Stack push insert node. Yeah, literally the same function. Cowabunga. Why do I keep running this outside the debugger? U32. Now we might find legit bugs in the game as well. We'll see. That's probably a U32 hash. Why did we not? It won't look it up now. Refresh entity parameters. Line 1120. Yep. There's just going to be a bunch of random stuff like that. Why are we not finding files all of a sudden? Sokoban, source, render, dx12. Hey, we found it. A.index. Oh, shit. These are unsigned. These are unsigned, motherfucker. Legit bug. Legit bug. Right, let's verify. This is descriptor heap dot block dot index U32. Well, I'm going to report this. Lol. Do you know? Okay, guys, all the misery that I've been through, the LLVM actually wasn't that bad, thanks to the help in chat. Thank you, chat. It took me like a day and a half to implement all this stuff. Maybe two days. Finding this bug might have taken an appreciable portion of that. Just one bug. This is how useful it is to have this kind of stuff in your programming language, right? Like, we will have paid off probably the effort of my doing all this just in the lifetime of this one game, with how many bugs we'll find and stuff, like how much time we'll save. Before you even talk about shipping the compiler to anyone else, right? Okay. I'm going to send an email. It's going to say, to the Sokoban product, seemingly important bug in descriptor heap stuff. Okay, I have been implementing arithmetic overflow checks for debug builds. They aren't turned on by default yet, but the plan is to do so after sufficiently marking up stuff that is supposed to overflow, like hash functions, etc. While doing my initial sweep, I ran into this. A.index and B.index are unsigned. So the that's also true in C, right? Like in C, if you subtract two unsigned, you're always going to get an unsigned, right? And it'll just wrap. So the delta will always be greater than or equal to 0. I think many languages compilers would find this issue during compile time. No, that's not true. Because there's no, it's perfectly legitimate. Well, okay. I guess what you would do is you would say delta is unsigned, so asking if it's less than 0 is never less than 0, asshole. That's what you would say. You would say error, delta is unsigned, so it is never less than 0, asshole. That actually would be a little better, probably, because it's a static check. U short minus U short gives an int in C. I don't know, does it? I mean, I know there's temporary promotion to int. But it doesn't. See, we have conflicting. See, this is what's so funny about this stuff is like, regardless of what the right answer is, the fact that we have conflicting opinions about this means that like a lot of programmers just literally have no idea what happens, right? And that's just C code. All right. Seems like they should be signed. Oh, Godbolt link. Let's take a look at Godbolt link. Well, I mean, this does catch it in the sense that the compiler knows it's just not an error. It's doing its like, see, this should be an error, but instead they're doing their sneaky fucker thing of like, oh, we're optimizing the code. It's so confused and messed up. Wait. I didn't realize I didn't have the display on when I did that. It's this. Yeah, it doesn't warn about it. But that's what's funny is it knows, but it still doesn't tell you. It knows, but it doesn't care about you. It only cares about what it can do to your code. It's been a very productive day. I feel good. I had a bunch of not unproductive, but moderately productive days for a while, and it's good to have one where we crank. x86 MSCC gives a warning, expression is always false. That's if you have warnings turned on, which like, dude, well, it depends what warning level that is, I guess. Dude, I just basically run C++ with warnings very minimal because I can't deal with how stupid most of them are. And then there's stuff like on Clang and GCC, you can handpick exactly which warnings you want, except they change the identifiers for all the warnings like all the time, and then your make file's out of date and whatever. Like, ugh. You can get a signed value when subtracting two unsigned ints. Really? Let's go back to Godbolt. Unsigned int A equals 20. Unsigned int B equals 30. Auto C equals A minus B. Unused variable. Return C. So this is giving us a signed result. However, that doesn't... See, this might be because this... What if I... See, even if I change this to unsigned, it's still going to say -10 because it gets casted to signed here, and that changes it. So the question is... Actually, the question is the following. Bool D is C is greater than 0. Like that. My close brace went away. Oh, there's no cast. Okay. This thinks it's positive. See that? Because you have A minus B is greater than 0. So it was really the cast to int that was making it negative again. D is 0? No, D is 1. D is 1. The return type is int. Oh, you mean here? I mean, here it would probably, if we make this int, it would probably be -10. Yeah. This says 0. So the auto is making it unsigned. Compiler returns 0. Oh, right. Yes. So it's interesting, right? Whether this is auto or int changes the answer, which makes sense, right? Now going back over here, this is the equivalent of auto, right? Hence the situation. Anyway, it's been a good day, huh? It's been a good day. It's 10 p.m. I should do some Tai Chi and go to bed. Except it's still a little early. I don't know. My sleep schedule's been jittering around a little. Will I upload the Lexa project to YouTube? I didn't feel like that was worth it because it was just a bunch of grungy porting. You know? You know? All right. Doing it again. Cowabunga. LLVM build. Let's see where we get to. Hey, look, we're running, guys. We are running with bounds checks enabled. And it's not slow. All right. I decided to go to the overworld. String to int. Our string overflowed. Oh my God. Look at that number. Where the fuck is this? See, this is like, it's like, oh, there's crap in our data somewhere. What the actual fuck is going on? Wall data. So that's a bit field. Why would we save out a bit field that overflow? Maybe it's just the way we're doing it is wrong. No, because like we're multiplying. We're like 2 digits before the end. And this integer is supposed to be representing some bit field, which means we're like loading wrong. That seems really bad. Like, this would imply, because we, like it's an integer. It's just an integer representing a bunch of bits. So like we must have had it in an integer before writing it out. Some must be 64-bit, right? Yeah. And it's not like by a factor of 2 because we have an entire other digit. Am I sure I'm not summing character of number? Yeah. No, if the error were that bad, the game wouldn't run. No, we're subtracting out the 0 right here. So base is 10. So we multiplied by 10 and we're trying to add 8. But then it can't be signed versus unsigned because we would cycle around again. This one's a mystery to me. So so obviously this was fitting, so we're very close to 2 to the 63, right? So what is 2 to the 63? It's rounding it off. Wolframalpha.com. Dear Stephen, what is 2 to the 63? Nine two two three. This is 775. 808. This is literally. Wait. Oh, right. We can't do 2 to the 60. We can do 2 to the 63 minus 1. So this is literally 1 higher than we can do. Am I sure that string is not actually a really big number that overflows? Well, what I'm saying is the code that serializes this out had to have that in a thing. But again, yeah, maybe, you know what? I bet it's supposed to be unsigned. I bet we save it as unsigned. I thought I saw a minus sign in the string, but I don't now, so I might have hallucinated that like ChatGPT. So, okay, so clearly we're printing it as unsigned. All right. Let's just put no AOC on there and we'll put a comment about why. We have marked this. Oh, actually, we say what the type is. Hold on. We say what the type is. So why are we string to inting? To integer load single value of a Yeah, see, the deal, we've just been sloppy. We've just been sloppy with loading and saving numbers. So as a result, predictably, like we're kind of poking it into memory, and we're saying as 64, but we really don't care if it's signed or unsigned because we're just poking it into memory. And so we don't care if we load it as the wrong type, etc. So maybe this is a good point to take a break because it's interesting to think about where the line should be drawn about what you let be messy and what you don't. Maybe we have a different function called toIntegerStrict that says, throw if it overflows. You kind of don't want to use that most of the time. Like, let's just say I have a text input widget and I type a number and it's bigger than S16, right? I mean, maybe you should throw because you also shouldn't be like anding that to S16, I don't know. It's an interesting question. But I am starting to get tired. And so it is 10 p.m. my time. And we really have streamed a lot today. And we got a lot done. And we're finding legit bugs. This one I don't think is a legit bug, but it is a little messy. And I would like to think about how to make it a little less messy, but I don't exactly know. Could that string be modified after being serialized? No. I'm pretty sure we're just serializing it as unsigned. Although that said, I mean, I guess it depends if there's more digits or not. Hold on. Let's go back here for a second. So cursor, oh no. See, we're about to end the loop here, actually. Because cursor is going to +1, and then it's going to not be less than the count anymore. So, yeah, this is just something that we wrote as unsigned, I think. Maybe we shouldn't do that. I don't know. We could know AOC this and just have it have its own checking. Like, if the value ever goes down, because we multiply by 10 and we add a digit, right? So if the new value is ever lower than the old value, we fucked up. Except we didn't, because in this case, that's going to happen. Yeah. So I don't know what to think about this. My inclination is just to mark it with no check and put a big comment there. But yeah, this is a thing. The number is reported as negative. I mean, it's, yeah, like we're loading it as a signed value. That's sort of part of the problem. In the language I hate, which one? There's a lot of them. They check if string is going to overflow a variable before they parse it into number. I mean, that's what I just said. I mean, you can't actually do that's what you said is not true because you have to parse it into a number to know if it's going to overflow. There's literally no way to do that without parsing it as a number. You could say you check if it's going to overflow before you store the result. That's totally reasonable. But you can't actually magically know if a string is going to overflow or not without actually mapping that string to a number. All right, everybody. This is it for me for the day. Thank you for hanging out, and we will, I don't know, we'll continue on this line a little bit. This is good that we have gotten to the code quality zone here. Thanks a lot. See y'all later. GG's.